Hello everyone, welcome to the video explanation for Brian Passwater's Topic 2-1 notes. This video is going to cover the background information for geometric sequences. So a geometric sequence is defined as a sequence where successive terms have what's called a common ratio or a constant proportional change. What we mean by that is that the pattern between terms will be a constant multiplication pattern. Now, it is possible that you might recognize this as being a constant division pattern. Remember that division is multiplying by a fraction. So that would be the same thing. Now that common ratio is going to be known as R. Okay? So again, there are two different equations for this, for the nth term. Remember that G sub n is going to be our nth term of our sequence. The first version comes with G sub 0, which is our initial value or initial term, our y-intercept, although we don't really have a y-axis here. And the R is going to be our common ratio. Remember, that is the value we are multiplying or dividing by, well, multiplying by each time. If it's division, R should be a fraction. And then K, remember, that's just another term, the kth term. And remember that n is always greater than k. It has to be a term that comes before the nth term. The n there is your term number. So G sub n would be like the fifth term, then n would equal 5. If it's the seventh term, n would equal 7, etc. Geometric sequences, they behave exactly like exponential functions, except they are not continuous, meaning they are discrete. Remember that what we're doing here is we are inputting whole numbers, and our output could be any real number. So we're not allowed to enter numbers that are not whole numbers. Our input, our domain, is the whole numbers. So this also means that when we get our graph, we absolutely do not connect the points in our graph. There's no curve, there's no line through them. Okay, so for example, down here we have G sub n equals 8 times 1/2 to the n power. So remember that this is in the format G sub n equals G sub 0 r to the n. So the initial value is 8. So we should be starting up here at 0, 8. Then our common ratio is 1/2. So when we go to the first term, we are going to multiply 8 by 1/2, which would give us 4. When we go to term 2, we're going to multiply by 1/2 again, which will give us 2. Third term would be 1, because again, times 1/2. Fourth term would be 1/2. Fifth term would be 1/4. Sixth term would be 1/8. We would just keep getting closer and closer to the axis without actually reaching it. Okay? So remember that that is how that works. We would just keep multiplying by 1/2 over and over again. So remember that also could be shown as a list of numbers. Something like 8, 4, 2, 1, 1/2, 1/4, 1/8, 1/16. Again, if we're looking at that there, we're looking for a pattern that is multiplication based, which would be times 1/2. So that 1/2 is your R value. Okay, that does it for the background information on geometric sequences.